we're looking for all the hydronium ion contributors. How about the first row? Did everybody get the first row? Zero, zero, good. Change? Yeah, well, we don't have to do the X because the K, we aren't going to be able to do any calculation here anyway. We don't have a number. So the K is very large. K is very large, then we're just going to assume it's going to be minus, you already know what X is going to be. It's going to be minus point. So you're left with 0. Plus 0.10 molar. And we're at 0.10 molar, 0.10 molar. Now, if we're just interested in the pH, then most of the hydronium is going to be produced in the second step. The only time, in the first step, sorry. And so most of the time we just stop here because, we wouldn't expect much additional hydronium in Ka2 and Kw, right? Unless Ka2 has a significant K value. Now, what is a significant K value? So HSO4 minus plus H2O liquid. What's kind of a big K value? We scan the K values. Obviously the biggest are going to be the very large, but after the very large, what's a big K value? After the very large, what's considered a big K value? We looked at Appendix D, which is more comprehensive than this. But the biggest one we saw was 3 times 10 to the minus 1. 3 times 10 to the minus 1. When I look at Ka2 for sulfuric acid, it's 1.1 times 10 to the minus 2. This is big. This is fairly big. And that means this is fairly acidic. In fact, how acidic is it? Well, take a look at the chart here, and then look at the border between strong acid and weak acid. If we look at the border right around hydronium, right at the border is oxalic acid. Oxalic acid is pretty strong as far as weak acids go. What is the K value of oxalic acid? Ten to the minus 2. And sulfurous acid, and then followed by hydrogen sulfate ion. If you look at bisulfate ion, it's pretty acidic. It's got a K value of 10 to the minus 2. What was that K value of 3 times 10 to the minus 1? 3 times 10 to the minus 1 was trichloroacetic acid. Some people call trichloroacetic acid a strong acid. It's really quite acidic. But trichloroacetic acid doesn't appear on this chart here. And so, when I have a large K value like that, this K value is 1.1 times 10 to the minus 2. Even though that doesn't seem so large, that's large in terms of the K values for acids. And so in this case, I would worry about step 2 contributing additional hydronium. And so if I wanted the pH, I wouldn't stop at step 1. I'd actually go through step 2 because of the fairly large K value here. And so I'm going to get 0.10 molar here initial. And then the hydronium, remember this is a common species here, we're going to drop it. So we're going to have 0.10 molar here and then 0 molar here. And so this is going to be minus X, this is going to be plus X, and plus X. It's on equilibrium. And so when we do the calculation, because of the simplifying assumption, X is just going to equal K. And so I'm just going to make this short. X is going to be 0.011. And so this is going to be 0.10 plus X, which equals 0.10 plus 0.011, which is going to give me 0.111. And so it looks like about 10% additional hydronium comes in from step 2, which would impact the pH significantly. And so I'm going to stop here since we're out of time.